Hello, I welcome you to Physics 4C for College, and the very first unit we're starting with is called Motion and its Applications. Today's topic is a review of two very important concepts when it comes to our first unit. We need to know our trigonometry, and we need to know our Pythagorean theorem. The only trigonometry we need to know is from your grade 10 applied course. That is the extent of the trigonometry. I'm not going to be teaching you anything new. So our goal today, I want you to be able to use SOHCAHTOA, and I want you to be able to use Pythagorean theorem in real-world applications, because in the next couple of lessons, we're going to be using them in context. So the first thing I want to talk about is your calculator. First thing, if you can make sure your calculator is in degree mode, very important, because we will be working specifically and only in degrees. And once you make sure it's in degree mode, we're going to be working with some very large numbers and small numbers throughout the course. So it's very important that we know what and how to use scientific notation. So the exponents and exponential notation are always the tricky ones. So converting between scientific notation and expanded form. So this is your scientific notation. Scientific notation will look like this. Now on your calculator display, it's going to look something like this. It'll be 3.25, and then on the display, it'll have a times 10 showing and a 6, or, so this is what it'll look like on your computer or calculator screen, or I've seen this notation as well. So both of those are scientific notation on the calculator. So when we want to go to expanded form, or the normal notation that you're more comfortable with, the 6 indicates how far, or how far to move that decimal place across the number. So what I'm going to do, I'm going to write the 325, and now the decimal has to move 6 spots to the right because it's a positive. So when positive, exponent, move decimal to the right. If negative, we move it left. All right. So there's your generic rule, your general rule. So 3.25 times 10 to the 6th, that means my decimal place has to move 6 times. So it was here. So once, twice, 3, 4, 5, 6. This is where the decimal is going to end. What we do is we need to fill these spots with placeholders. So we add zeros. So 3.25 times 10 to the 6th is actually 3,250,000. Okay, so one more like that. So 4.287 times 10 to the 3 is the same as, write the number out as per normal, 4287. And you don't need to show this, but I'm going to show my steps once, twice, 3 times. So 4.287 times 10 to the 3 is just 4,287. All right. Now if we have a negative exponent, going back to 3.25 times 10 to the, let's go negative 6 this time, we now have to move the decimal place to the left. So what I do is I write my number over here. I leave lots of space. So 3, 2, 5. And similar to what I did above, here's where it started. I need to move it 6 spots. 1, 2, 3, 4, 5, 6. This is where the decimal point is going to end up. In order to do this, I need to add placeholders to keep that decimal from sliding back. So this 3.25 times 10 to the negative 6 is actually a really, really small number in the end. All right, so 4.287 times 10 to the negative 3. Again, write the number when it's a negative exponent. I always leave space. I need to move my decimal 3 places. And again, you can do this mentally. 1, 2, 3. Don't necessarily need to see it. So I need two placeholders in that case. So there is the difference between scientific and expanded form. All right, so moving along, using it with your calculator. So on your calculator, you'll need to locate one of two buttons. There is either going to be an EE button, or, and this one, EE button's the more common one, or I have seen EXP as a common one, and some calculators have that button there, times 10 to the X or something like that. Okay, so when you have these big numbers, you don't have to convert back and forth. All right, so for example, if we take our 3.25 times 10 to the 6, and we want to multiply it to the 4.238 times 10 to the 3, we can just use our regular calculator application here to do the calculation. Your calculator will do this for you. So I'm going to use the Windows calculator, but it works with any calculator. Now you'll see that there's a 10 to the X button and there's an EXP button. Now both of those buttons, they look similar, and people tend to use this one, but that's not the right button to use here. All right, the button we want to use is the EXP button. So that's where we are going to start. So I'm going to punch in 3.25 EXP 6, and you'll see that that E notation tells me that I'm using my scientific notation. Then I simply hit multiply by 4.328 EXP3, and I hit equals, and my calculator will spit out a very large number, and it's fine. I'm not too worried if that's the number you write out. However, to save myself some time, I'm just going to write 1.4 times 10. If I bring that calculator up, I count my decimal places. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1.4 times 10 to the 10th. And most calculators, the handheld calculators, will automatically do that for you. Okay, so you can do any operation that you want with the calculator. Let's do one more. Let's go 6.38 times 10 to the negative 5 divided by 3.1 times 10 to the negative 8. So using negatives. So it's the exact same process as what we just did. Oops. And we punch in the 6.38 EXP. So you don't hit the multiply button. You put EXP to the negative 5. And there's what it would look like. So 6.3 E to the negative 5 divided by 3.1 EXP 8, make it a negative. I hit equals, and I got 2058. Okay, so you do not have to convert every time to this notation here, our expanded notation. The calculator, it's much quicker just to enter it in as is. All right, so moving along. Pythagorean theorem, only for right angle triangles. So that's only for right angle triangles. All right, so for any right angle triangle, we have the relationship with sides A, B, and C. C is always the hypotenuse. Always hypotenuse. Okay, and their relationship is A squared plus B squared equals C squared. So there is your formula, and nothing's really changing from grade 10. We're just going to use it in a couple applications. So for now, I'm just going to give you a generic question here. So find A for the first triangle. So here's my example. So if I have, there's my A, 3, and 7 for the hypotenuse. Remember, our hypotenuse is always across from the right angle, and it is our side C. When we go to do our formula, this is what it would look like. Do our substitution. I don't know A, I know B, and I know C. Make sure, and I'm going to do all the steps here for the first one. You can skip steps as you feel comfortable. Square everything first. Then you need to get everything to the same side. So I'm going to subtract 9 from both sides. a squared equals 40. Final step, take the square root of both sides, as a equals the square root of 40. And you can use a calculator. I don't care if you leave it in that notation. All right, you don't have to use the calculator every time. Second example, if we're looking for the hypotenuse, which is always the, I think, easier one. So we're looking for C. So I'll say find C, 2 and 5. So again, you set it up, a squared plus b squared equals c squared. 2 squared plus 5 squared is c squared. 4 plus 25, make sure you square them first before you add them. 29 is equal to c squared. Take the square root of both sides, and you get c equals the square root of 29. And again, you can punch it. I don't care if you give me a decimal. It doesn't matter to me one way or the other. So there's Pythagorean theorem. Nothing changes from, like I said, the grade 10 math. Review of trigonometry. Remember that with a right angle triangle, if we have the right angle, it is important to label the sides appropriately. So if this is my angle of interest, so I'll call that the angle theta, we need to label each side appropriately. So I always start with the side that is across or opposite from the angle. That's our opposite side. We know from Pythagorean theorem that the longest side is the hypotenuse. So that means the remaining side is the one word that no one knows the meaning of, adjacent, which really means just beside. And we take those letters to form our acronym. So we take the O, the H, and the A, and from that we create, as you learned in the grade 10, SOHCAHTOA. Sine means sine of the angle equals opposite over hypotenuse. The CAH, the CA, is cos theta equals adjacent over the hypotenuse. And the TOA is tan theta equals opposite over the adjacent. So there are your 3 trig ratios, and that's all you're responsible for. Like I said, it is just taking your grade 10 math and applying it in the grade 12 college physics. You don't have to extend beyond the grade 10. All I want you to be able to do is find the angle and find a missing side. So I have a couple of examples of that. I got to finish it up in the next video because I don't want to rush and pinch this all in. First video is always the longest because it's a little bit of review work. So I'll see you in the next one to tie this up.